Good
Good evening.
evening, Terry. How are you today?
I'm great, thank you very much. Had a busy day talking to people in this country and in the States already today. So yeah, the American side's only just woken up a couple of hours ago, so this is all good.
Brilliant. It's what a great life we have now, talking around the world just in our armchairs, basically.
Yeah, the whole idea that we don't have to physically be there and visit people and go face to face. It's nice to do that sometimes, but it's not. It's no
Yeah,
longer essential, and we can get so much done remotely.
yeah.
It's great. Productivity is much higher. I spend a lot less time on airplanes.
I can imagine. I can imagine. Now, Terry, I know you from the past. I have the great honor to work for you in the 80s, when you was at Trend, and I'll probably allude to a story where I first met you, when you opened the door to me, at the offices, because I had to arrive early to pick my company car up, and there you was standing at the door, opening the door, and then when I realised who it was, I obviously become very nervous because there I am, the field engineer for Trend, and I'm dealing with the managing director at that time, which was, a great honor for me. And I always remember that story, and I tell everyone that story because that's my what I call my claim to fame. And thank you very much for coming. I know I asked you last year, and we sort of got a bit mixed up, but it's brilliant that you're on today, and thank you very much for that.
My pleasure. My pleasure. It's nice to kind of spread the word, and it's good to see what everybody's doing around who used to be in the business. And one of the things that I'm very delighted about is not just that that business has been successful, but just how many of the early people who worked with Trend have succeeded. That I'm proud of the business, but I'm also equally proud of how many people have become CEOs, leaders, started other businesses from that group, and that's fairly gratifying.
Yeah, I can
How
imagine.
family trees go in those pieces.
Yeah, well, it's amazing. So once again, thank you. So I know a lot about yourself, but it'd be very great for you to share with our audience today your background story and your origin story. Where did it all begin for Terry Casey in this industry?
Okay, so we started Trend in 1980. I was just 30. So there's not a huge amount of background to go for this stuff here before that. My degree is from Southampton, and I took a degree in electronic engineering, and I specialized in control engineering. There. So, surprise, surprise, I actually am sort of vaguely qualified in this domain, and
Right.
perhaps I actually have actually stayed in the whole electronic. Well, electronics tended to move into processors and programming and software, but into that whole area. So I started my business career in the car industry, with a part of what became Lucas, and developed systems for control of jet engines for cars, which may today sound a little far-fetched. But in fact, all the big car companies in the early 70s were developing gas turbines. Whether it be Ford, General Motors, Fiat. I worked on programs for British Leyland at the time. And it was interesting. So, a small team building a solution for these people, and I could actually play with my electronics and things. And this is before the before microprocessors came along. In fact, part of my job was to evaluate the very first Intel 4-bit processors
Oh wow.
for for this application, and came to the wrong conclusion. I came to the right conclusion for the day, which was we couldn't do everything with it, and it was a bit too expensive. Failed totally to forecast the what was going to happen with this new super technology. We were dealing with sort of discrete components and hybrid technology at the time. So I did that. Liked the job I did immensely, realized it wasn't going to go anywhere, and that after the 73 oil crisis and things. But it had introduced me as a supplier to a little company, well, not that little, in Worthing, called Eurotherm. And they were the leaders, world leaders in industrial temperature control using thyristors. So I joined them in 73, 74. They were great. They were very entrepreneurial. They let you do think if you fancied doing something, you did it. You didn't ask them, yeah, or you might tell them, but wasn't a big company of permission. So that's what gave me a very entrepreneurial taste to things. The company was hugely successful. Had 75% of its output was export. At a time when British companies were, it was called the British disease or malaise of strikes and
Yeah,
things
yeah.
there with Mr. Callahan having a hard time with his union credentials, if people remember that, the winter of discontent and things like that. So getting out of a union controlled environment into a very entrepreneurial one was super. And I saw how very good these guys were who ran the business. I was very close into the sort of the management director level, but not there myself. And but I also realized that they were fallible, that they didn't get everything right. In fact, they probably got only about half of the decisions right, but they were still hugely better than the average. So it gave me faith that I could go out and do something. Um, and I sort of said to myself, well, if I'm not running a profit and loss account or a business sector, by the time I'm 30, I'm going off and doing something myself. And that something was Trend.
Right.
And we in good classic things. It all started down the pub, and I was dealing with a particular guy who was an expert in combustion and combustion efficiency, and he said to me, "Why aren't you running your own business? Why aren't you doing your own thing?" I said, "Well, I would love to. I've got some great ideas, but I haven't got the money." So he said, "Well, I can introduce you to somebody whose company's got the money. Would you like to meet him?" So I said, "Yeah, okay." And we started, I met this bloke and said, we've got these ideas, a couple of us, we'd both done the same degree at the university, um, which was Mervyn. And this guy said, okay, I believe you guys. You can start up a business in this crowd. And this crowd was Holec, which was a Dutch a heavy electrical engineering group um, who turned out to have some real big need for innovation and to move away from heavy electrical engineering because people weren't buying new energy infrastructures. So anyway, we set up this business and get it going. And about little under 2 years into it, when we were still loss making, the company broke its covenants with the bank and got basically run by the bank. And so they said, well, we've either got to shut you down or you can do something else. So we found some finance, venture capital, which was extremely early stage for venture capital at this
Yeah.
stage, 1980. Um, and we bought the business out from the Dutch with the help of this venture capitalist. And that became Trend. So that was an early building management system company. But the
And where did
point,
where did the name come from originally? What made you call it Trend? Any ideas?
um, well, the whole thing was that it was the trend of the industry. But the other thing
Right.
was the first company to put in trending
Right.
in
Yeah,
terms
yeah.
of data capture and on all the variables in the system. So we could use, I think it was 96 points in a day, 15-minute data intervals, and we could display these on little tiny Hewlett-Packard desktop computers. This again, there was several years before Intel came out with the all the things that we know about, and desktops as we know them came out. So this was a very early form, but it had graphics on it, so we could build little graphic screens,
Right.
and that was one of the first things. Um, and yeah, so we came up with that name as being descriptive. So everybody that went on platforms and talked about trend logging went, oh, I don't mean the company, I mean the technology.
Yeah, yeah.
So it was good advertising when we did that
Brilliant. Yeah.
um, around. So yeah, and the industrial control and the process control I'd been part of, um, and also the stuff I did for the automotive industry meant that we understood what control looked like, and it was clear that the building control industry was behind the curve in terms of what it would do. It was hadn't picked up the innovation. At the best, it was doing hybrid systems, which were a sort of mini computer
Hmm.
supervising conventional analog control systems. So what we did was we introduced some of the first of the true microprocessor DDC systems. And I can remember writing pamphlets or booklets, as well as giving many talks about what is DDC. Yeah. And some of our competitors going, oh, it's digital, it's on, our system is on or it's off, therefore it's a digital control and DDC control. So that really wasn't what we meant. We meant using continuous control, three-term control. And so we were, one of the pioneers of that movement, arguably the first people around with distributed microprocessor controls, which could communicate with each other and build a complete network for the building. And having built it, it was the sort of second generation, which was the IQ generation of those. Then that actually worked. It was robust enough that we could take it to market, and you couldn't, the guys who engineered it couldn't break it. So we could actually give it to engineers and say, okay, off you go. What this
Yeah,
thing will do whatever you tell it to do.
yeah,
You can't mess it up. The systems which came before that, and even Trend's first generation system, was not like that. You had to get into the programming of it and tell it how many of this type of control loop you wanted and that kind, in order that we could use the processor power properly. But if you got it wrong, you said there were three, I don't know, six optimum start groups rather than five, or the other way around, which is more common, then the thing stopped. And,
right,
and this was the common for all the products which were around at that time, that they needed an IT level competence and programming competence.
yeah,
So they were hard to use. What we brought out with the IQ range was the ability that you didn't need to tell it how many of this and how many of that. It was all pre-ordained that you could use it. And we underran the processor. So we actually underloaded the processor quite considerably, so that you could actually get this characteristic. And it meant that we could actually then sell this through third parties. So we found the third parties who were currently building reasonably sophisticated controls, typically using hybrid analog systems, and say to them, and they built control panels. So they built these into control panels. So
yeah,
our value proposition to them was very much, okay, this is eating your lunch. Would you like to come and own the restaurant as well? Can we
yeah,
actually sell this through you guys?
yeah.
And we got really good take up. Not instantly, but we got really good take up. So we not only built the technology, but we built a new channel of people who could take this technology. Up to this point, everything was turnkey projects from the manufacturers. So the technology we developed, we managed to adopt it so that it could actually create this new channel of go-to-market. The Americans, which was the other part of the world where this sort of stuff was being developed hard, they had channels as well. They sold through value-added resellers, but they were very different. They operated regionally. And so the suppliers would say they acted as distributors as much as value-added resellers, but we really did pioneer the value-added reseller market. And
I
that
think as well, one of your secret weapons, and I boast about this now, was this thing you developed, which is the convention. So you had like a digital array, and you had these analog points, which would would be exactly the same all the way through, whatever system you designed, whatever
Mm.
product. For me, sensor one was always the outside air sensor. Boiler one would always be driver one. That convention, I think you developed.
Yes.
People was able to remember that. It's very easy to program at the time.
Yeah, so what we did was in the products that I played with in Eurotherm Group were process control, and we built process control systems out of physical modules. So you'd have a three-term controller, you'd have a sensor module, you'd have a logic module,
Yeah,
and my one of my main jobs was to build control solutions using these physical building blocks, and then the way you got them to interact was a wire loom behind. So the output of this one goes to the input of this one, and it was all based on 0 to 10 volt
mm,
logic, analog variables. So what we did was we reproduced that in the trends. So effectively, we built like an analog computer system, but in the digital world in DDC. So you've got these standard building blocks, and those arrays that you talk about were patching them together. The
Yeah.
standard building blocks were being patched together, which gave huge flexibility, which we understood clearly from our process control work that we'd done, and we used to do all sorts of
So that
things.
that great work you done then, I'm still, if I ever come across a trend system,
Mm.
I can still go back to that. People are shocked that I haven't seen trend systems. I worked on them for many, many years, but I can still go back and still work on them because
Yeah,
of that convention.
the
That's the
building
amazing point, isn't it?
the building blocks that we and the mechanisms that we came up with there have stood the test of time.
Amazingly. Yeah.
Not everybody in the industry uses exactly the same mechanism, but most do. And in a way, that was the precursor of the industrial control standard of C1131 standard, which is the IEC standard in programmable logic controllers.
Mm,
It uses exactly the same building blocks as we
yeah.
did. All we had to do was add in time of day things.
At that time as well, I talk about these pivot points for me. Also, backward compatibility. The product moved very quickly when I was. So I started with IQ 150s, then it was
Mm.
151s, then 151 plus, then the 251s, and I think shortly after. What I liked about the product, if I was a customer looking back at that, was the backward compatibility of it all. You could upgrade very quickly and very easily.
Yes, the we made sure two things. One was that um, the communication network between the nodes, the devices, the IQs, was consistent. So you could run an original 150, yeah, or even the original 100s, yeah, with a 150 or later with a 250 or a 350 on the network. We realized that a lot of people who were building network solutions there were getting products which got orphaned. No, oh no, that was last year's model.
Yeah, yeah,
If you want another one, you can't buy that anymore. You've got to change the system out,
yeah.
which didn't exactly make them very popular
No.
with the customers. Um, and I mean, the number of things which we did. This is way before standard network open protocols and things came out. But we tried to make the whole thing as open as possible for everybody.
Mm,
Um, Realized talking to the customer networks that one of the things that they resented hugely with the traditional companies was that they didn't let you do anything yourself.
yeah,
So they had you captured, and they would, in a nice way, milk you for ongoing service
yeah.
and maintenance and looking after your systems. And that was where they made most of their money. They didn't make their money on the standard projects. So we took a different approach and said, no, the customer owns this stuff. We don't. And he doesn't have to come back to us in order to do any updates, engineering extensions, or whatever. So we took away the lock-in that the companies um, had managed to achieve with those, and said when we set up the value-added reseller network, which became a Trend Technology Centers, one of the insistences was you must hand over the engineering files,
Yeah.
the source files for every controller to the customer, which meant that they couldn't get locked into any one supplier, and that they could go to any of the Trend Technology Centers and say, I want an extension to my system. So both technologically, the products went forward. As you say, you got backward compatibility, but it also meant you could go to any of the, however many centers there were around, and get your system looked after, because that information was forced to be available. So it wasn't so much that it was open technology in terms of communication systems and standards, but it was that you couldn't get locked in. And when you talk to people about what they wanted from their systems and why did they want an open system, well, it was not that they really needed an open system. They actually just didn't want to get locked in and screwed by the suppliers.
Mm.
So we took that, that very seriously, and it was respected. Um, Before that, though, the other bit which was interesting, I think, was the huge amount of work we had to do to inform people about what these micro-based DDC systems were about and what they did. And we realized that if people came to us and they took the time to understand this stuff, I mean, and that doesn't mean just sitting to, half an hour listening to a sales presentation in there, but actually got to get their hands on the technology and understand what it was about, then we demystified it. And people largely came along and said, "This is now we understand it. This is
Yeah,
easy and very very powerful." So we spent a huge amount of effort on education.
yeah.
We ran training courses.
You
We
had an
ran
amazing training center, didn't you?
Yeah, well, we that came about a little later. To start with, we were going out doing seminars around the country. We'd invite people to come to a seminar for half a day.
Yeah,
We There was this famed sort of thing of sensor loop driver. We would tell you what these are, and you'll build a control system, and
right.
it will. And once people have done that, they got, oh, okay, I now understand this. We donated kit to colleges who were running courses around them. We were able to run through full training courses, which took 3 days to a week. We would bring in college lecturers and give them free training during their vacation. We'd support people the students to do some of these things, or they'd use them on their courses. So it's really about getting the deep understanding, because this was a technology shift. So it was a major departure. So we had to do what some of my friends in the industry call, the Americans call heavy lifting, which is it's not so much selling, it's informing, it's educating the
Mm,
people about what these systems did, how they worked, to take the fear factor out and to get them away from being stuff which is geeky. I remember my partner and I were described in some of the media as computer whiz kids and things which
really?
which was, far missed the point. It wasn't the computer stuff. It was about understanding the principles of control
Yeah.
and how we could make these systems work and deliver coherently to the people who wanted to use the systems, to actually give them energy performance, energy efficiency benefits, visualization of data, and all those things.
I know at the time you was doing some considerable amounts of talks
Yes,
regarding the
yeah,
product. I think
yeah.
you was leading that, wasn't you?
Say again, please.
Was that being led by yourself? Most of
Yeah,
them,
I,
them
I,
talks
I
was
I,
was
I
like
was
that.
the guy up on the platform.
Yeah.
At the time, the UK government was sponsoring some various bits of energy efficiency innovation. And BMS systems was one of the sectors that they picked on. There were others as well, including heat recovery and others, which didn't actually make it to commercial success so much. But the government then they had this energy demonstration projects, and the Atomic Energy Authority at Aldermaston gave technical experts so that they came along and sort of vetted the projects and wrote reports about how well they worked or didn't. And that gave us a platform to go out and talk about the projects we were involved with, but also about the technology. And there was a healthy government-sponsored network of seminars and workshops and things which went around the place, which they typically sort of did a morning sessions, a few talks, and a buffet lunch, and then everybody went home. But the government were very helpful about pump priming this technology. And of the ones they chose, the BMS industry was the one that was the poster child that actually worked. So I'm not a great believer in government intervention in most things, but this is a particular case where their intervention was welcomed and timely, and they put a little bit of money into it. But frankly, the real thing they did was to publicise the results and give credibility to them.
Yeah.
There were a number of British companies who did well out of that, particularly um, you got John Lawrence's company, JEL, which got sold off, Transmiton, who came out of the mining industry and telemetry systems in there, did well. and we were vying for the sort of top slot in the industry. And of the there was a serious magazine that was called Energy Manager, and it did a study in about 1983, I think it was, um, for people who were making and supplying a distributed intelligence microprocessor-based energy management systems for buildings. So quite a tight definition of these. And I think they identified over 100 companies who were in that industry. Um, of the innovative ones who came in and the new ones, I think there were three who ever made a profit, and Trend is the only one that's still there.
Yeah.
So, it survived against the odds. Obviously, it's not independent. It got bought out, which is a characteristic of all venture capital-based companies. It's very hard
Mm.
to keep ownership of
Yeah.
them
So
because the venture capitalist wants his money back, and
exactly.
with lots of interest. And
Yeah. So
Trend was
what year did you actually step down from trend as such, and what was that decision? How was that made?
93.
Right.
I got out of that in there. Yeah, I mean, there's two or three things in there. The um, I believe that different people need to, with different characteristics, need to run businesses at different stages.
Mm-hmm.
And businesses go through a life cycle in the same way as technology or products go through life cycles. And you've got the startup phase, you've got the innovation phase, which goes on, and then gradually your business becomes more mature, and it needs different characteristics. It needs less innovation, and it needs more people who can manage the books and do the accounts and what I call turn the handle rather than innovate and do startling things.
Yeah.
And I'm arguably pretty good at the early stages. And I get bored at the things when what we used to call it the grey suits come in and the accountants come in and just the object of the business is no longer high growth and innovation, but it's much more about efficiency and reducing cost and reducing variety. So I think trend in the first of the first 10 years that I was responsible for it, I think the first seven we had growth rates above 100% per year.
Right.
And the challenge of running a business with very high growth rate and pretty high innovation rate as well, the rate of product innovation in that is challenging, but it's not the same challenge as you want to do at the as the company gets more mature. It became the market leader in the by the mid 1980s, and then continued to grow from that. So
Yeah.
it's a horses for courses thing, and we'd also sold the controlling stake of the business when the venture capitalists we started getting offers for the company, unsolicited offers, people coming in who saw the growth of both that sector and of Trend's position in that. And they said, well, okay, we want some of that, and that's what they do. But they also bring in other constraints and things on business. The people we sold it to were well intentioned, but they didn't share my belief anyway in the potential of the business to continue to grow while we had arguably technology superiority. So, I wanted to keep growing it. I said, give me more money. I don't particularly want to enter the US market. That's a big graveyard for British companies. But I do want to develop the overseas businesses we've got a lot more. And the answer was, yeah, okay, but provide us all the cash and the profit first, and we can do that. So that led to a natural sort of schism that they wanted a business which was generating profit, not and less growth.
Mm. And then in '93, you stood back. Did you take some time out then, or did you go
Yeah,
straight into something else?
I did the standard thing of thinking about what to do for a while, and then I started another business which was called Sea Change,
Yeah, I
which
remember. I knew you was
on
going to
my
say that.
CV, is not quite a blot on the copybook, but it's the least successful business I've been
Right.
involved with, and uh, and
Was that with
the
Mervyn again? Is it you and
yeah, yeah.
Mervyn?
But Mervyn had gone and literally taken his boat and sailed the high seas for
Yeah, yeah,
2 or 3 years, and he came back, and we kind of restarted in the next business. But I think the main story is trend, and how that developed and worked, and how it was a combination of technology, marketing, a channel, and working out how to penetrate a market and realize what the real things people were interested in.
Mm.
Um,
And
and
I think the culture you developed there at that time, you mentioned it earlier about how you're proud about how people have gone on. You developed a culture there, and that culture is still going, and there's still people within Trent that are still exactly the same, following that same culture that it's maintained.
yeah, I hope so. I mean, you a bit like your physical offspring. In there, one, you're very keen for them to do well,
Yeah,
and secondly, you like to think that some of the values persist, the good ones, through there. But you've got to let go.
yeah.
Yeah, you can't maintain that sort of thing.
And what you're doing now? You're still in? Well, I see you every year at Emex, and you're very active there. So what's Terry Casey doing now?
The after the sea change business, which wasn't very successful, I got asked if I'd like to participate in another startup business in the States, which is Tridium.
Right.
Tridium developed the Niagara framework, and it was the first framework technology to come into the building and automation space. You know, and it met a number of criteria I had, that were that it was a new innovation approach, to heavily IT orientated, handled multiple protocols, different standards, and proprietary and open, and was what renowned in the industry for a couple of things, mostly about supporting true open technologies in BACnet and LON and others as well. But also, it was the first one that actually did web serving. So that appealed to my innovation and technology piece there. So I took on the role of president for EMEA, Europe, Middle East, Africa, for that technology. And that very similar story to the trend one. Great technology, great people to work with, and innovative there. And it needed marketing through explanation. But
Mm.
what the hell's an automation framework? Well, people didn't know, and we spent quite a long time trying to work out how to explain it, and obviously what its benefits were. And we reran the playbook to some extent, which was create very good training, education, and very good technical support for this product, because it needed it needed understanding to be able to bring this out. But people understood it as supporting open networks and open web serving information systems, so the web browsers and things were being used, and it worked. It was a venture capital backed business there, which was burning through quite a lot of money. So it was had issues about having to get profitable. But this is another innovation story about coming into the market. And now that technology is used not just within Honeywell, who bought it eventually, again from the venture capitalist, but it's also used by all the major controls companies, whether
Yeah, yeah.
it's Trend uses it for its IQ Vision, for its web serving head ends. It's used by Schneider. It's used by Siemens. It's used by Johnson, as well as the second tier, what I call second tier distributors, which is in America, in Canada, Distech and others have used it. So it's been hugely successful as an OEM product. But that also led into what I consider my sort of next and even current phase of work. One of the things that I recognized in the BMS world, and this is not um, supplier company specific, but when the generic stuff it is, it was very good at doing control.
Mm.
It wasn't very good at working out what wasn't working. And very often you'd get this very good technology being put in and people didn't apply it particularly well, or they didn't recognize when the equipment that they're controlling is going wrong. It's not the control system's going wrong, it's the equipment usually
Yeah,
goes
yeah.
wrong. And you end up with a huge number of equipment faults, overrides, and people sort of in a well-meaning but idiotic fashion trying to make the right calls when they didn't really know what was going on. So you end up with systems which are underperforming in the buildings there. And I got introduced probably, well, at least 15 plus years ago, 20 years ago, into the concept of Internet of Things, and where you take the data out of these systems and you process it and work out what's going right and what's going wrong. And you create more value than just the supply. So I got very interested in the IoT space, and a number of sort of leading thought leaders in that area as well, and listened to them and realized that the tritium technology was very close to being a solution for IoT because it had got all the networking, it had got the ability to talk to lots of different systems, you could extract data from it. But Tritium wasn't very interested in going beyond the conventional automation area. You know, they'd done their innovating with the web servers. Um, and so I left that and went to join what is one of its biggest independent customers, which is Pacific Controls in Dubai, in order to build a proper IoT-based business for them.
Right.
Um, and at a similar time, um, the originators of Tritium, which had now been bought by Honeywell things, and they stayed with it for the statutory period and then left. And their next startup was IoT based. So this is a Sky Foundry people who are the same people as originated Tritium, and they came out with the Sky Spark analytics platform, which can be used to detect the problems that the BEM systems are not able to. So for the last several years with Pacific, I was building this IoT solution in there, and it worked. It was hard work, but it worked. It's a different concept. It's a service business. You know, you run it to operate the buildings, whereas traditionally controls, it's I design it, fit it, and largely go away again, except maintaining it. But this is a dynamic business, and you can get some significant benefits by spotting the problems using analytics. So probably for the last 15 years or so, I've been heavily involved in the IoT business. And I still am. I've got customers in UK and mainland Europe, but also a huge amount in US. I've spent most of my business time in the last 15 years or so in US orientated, although last couple of years I've been doing much more back in the UK. And after Pacific, when it got its demise, they got some other things wrong and overreached themselves and couldn't fund their growth. But they had the right ideas, and for the last I know, it's about 10 years or so, I've been advising companies how to build IoT solutions. Um, the number of competencies and skills you need to build a building IoT business is actually very broad, and very, very few organizations and people have the capabilities because you know you've got to understand the buildings, you've got to understand the controls, you've got to understand networking, you've got to understand cloud computing, you've got to understand your remote communication through cellular and pieces like that. And they're sort of skills that I seem to have acquired over these years going through the processes there. And it still seems very few people have built actually successful IoT businesses in buildings. And so the people are, I've got to an age and stage of life where I'm sort of well past official retirement age. And so I don't want to actually do it myself, but I
Yeah,
don't
yeah.
mind trying to help other people
But
build
do,
their.
do you still do you still roll your sleeves up and get stuck into the programming and things?
Yeah, I mean, but what's the characteristic of any business in there, but in particularly this IoT stuff, is the devil's in the detail.
Yeah, yeah.
You can understand the concept very quickly. You know, hey, technology, data analytics, all the AI and all the buzzwords of today going on. But and you know, you can understand conceptually how this is going to lead to a business which or businesses which are beneficial to the world, the environment, and and make money, which is what businesses are about. You know, but there's precious few people who've actually done it, been there, and got the T-shirt, and maybe some scars as well from the experience in them.
Yeah. You
And you have
mentioned you mentioned AI then, and I'm surprised you hadn't mentioned that before when you was talking about the IoT. Where is AI with BMS building management systems now? Is it going to be playing a big part, or is it still a bit too early yet?
I think that we tend to use the AI label liberally, which is good, perhaps, but
Yeah,
also broadly. And you've got to define a lot more what you mean by it in the context.
yeah,
So if you think about analytics as being a part of AI, which it definitely can be, where you use the rules and algorithms that you've created to find the problems which are in the buildings, which are stopping them being very efficient or causing call outs or whatever malaise you've got there. Yeah, if you call that AI, but we tend at the moment to be giving AI a broader base than that. We have expectations about it coming in to do all sorts of things for us. We've just had Keir Starmer on the television today, muddling up two or three things about wanting Britain to be a world leader in AI, and then talking about how the UK public sector can actually use it to become more efficient. I'm a great believer that the latter should be the case. I'm very skeptical as to whether the former is going to be
yeah,
the
yeah,
right thing, but he seems to be trying to merge it all together. And good luck. But if we can get a bit more AI into, the things like digital assistants and being able to stop people having to do such mundane things, I'm all for it. But my use of the AI, I think it's very specific. So
yeah,
if I do something which is from something simple, relatively simple, like a self-tuning control loop, or more particularly using it as the way of analyzing the data which comes out of all these systems to realize what's going on and what needs to change and where the faults are and when the services are needing things, then yes, that aspect of it is being done. But I don't like using AI very much as a phrase because I think it conjures up an inaccurate perception of perhaps it seems like fairy dust and magic wands, and
yeah.
I'm much more into the
And let's just
practicality.
take that back because I remember when building management systems first come out, they were like the black art, wasn't they? But
Yes, and people,
trend took the black art away, and that's what you're sort of saying now regarding AI. You're taking away the black art again, aren't you?
I
I
suppose I
think that's
thought of it that way, but I think that's a good analogy. Yes,
yeah,
yeah, trying to get it back to the practical. What am I actually trying to do, rather than painting it in some sort of mystic, um,
yeah.
ethereal type of areas.
And
So
that's why I think if you look at the buildings around the UK, I'm sure the figures were something like 1 in 3 building has a trend system in, which is phenomenal. It might be more than that now.
I don't know. I mean, the sector that uses BMS systems is typically larger, more complex buildings. There's an
Yeah,
awful lot of buildings that don't. One of the things we did do with Trend, partly because we didn't have a legacy technology to support, which the other companies around mostly did. I mean, the Satchwells and whoever, Landis and Gears and people, was we extended the BMS approach into much smaller buildings, and where our competitors, traditional competitors, tended to try and just use it in the biggest high-end um,
yeah,
projects.
yeah,
Um, so we extended it down, and particularly with multi-site, retail, schools, whatever, and getting the benefits of what we're now calling IoT in terms of being able to remotely understand what those buildings are doing,
yeah,
because that remote engineering aspect is terribly important. The worst performing buildings are always the ones which don't have permanent engineering staff around.
yeah.
Um,
And the
the-
visibility.
yeah,
Yeah,
you haven't got somebody who's going around there with the oily rag and visualizing whether things are going right or wrong.
yeah, yeah.
So, yeah, so we did an awful lot of work in Trend, and I have subsequently done an awful lot of work using what I call multi-site customers, customers with you
Yeah.
know hundreds, thousands of sites.
Yeah.
Um, and programs I'm involved with. Well, in Dubai, we had 47,000 buildings connected into an
Wow.
IoT system for actually for fire alarm monitoring, but it's the same concepts.
Yeah. Yeah.
Um, the concept that to check that the fire alarm is working, the water sprinkler systems are working. Yeah, if you do that, you probably will pick up the alarms
Yeah.
um, rather than false alarms. But the yeah, and other programs I'm involved with now are thousands of buildings in a multi-site environment, and that's where you can really get benefits from the automation of the detection that we can and do. So yeah, so that's probably my sort of third innovation in buildings bit. We went from Trend, which is bringing DDC to the mass market, and then with Tridium, we ended up with open networks and web serving pieces, and now this my current phase is trying to help the IoT space because the trouble is that if the building is capable but it's not actually working the way it should, and the equipment's not working the way it should, you're not going to get the efficiencies. And
Exactly.
this, and
Exactly.
this is about getting information in front of people to get the efficiencies, which BEMS systems have never been very good at. They've been
No.
great at doing the control, but the alarming systems on them have always suffered from the problem of producing myriads of alarms, which are not real things that you want to
Yeah.
suddenly send the
And
fire.
you can never see the wood for the trees, could you? Really, you had so many.
Yeah,
Um,
and I think the current generation of IoT for buildings is capturing that, but its penetration into the market at the moment is still relatively modest.
yeah.
It's still an area which it needs to grow, and I think it's largely because not that people don't understand the concept, but this issue that they don't have the breadth of skills to be able to deliver it, or the. I'm also interested. I find very much that. Um, People don't quite know what to look for.
Mm,
They think they do, but they tend to revert and
yeah.
implement slightly better BMS systems, whereas you really need to get further into the analysis, most of which is actually quite simple. You just break it down, recognize what typically goes wrong, and develop some multivariable rules to do that, to pick that up. Some of it is some using statistics and real clever analytics, but most of it's actually just doing the stuff which is fairly obvious.
Well, Terry, it's an amazing story, and I thank you for sharing all of that with me. I've learned a lot. I didn't realize how hands-on you was with the technology, and thank you for sharing that story. It's come to that point. I could be sitting listening to you all day, but it's come to that point where I'd love to put you on the spot, and thank you for obviously the story and being on the spot today. But is there anything you can give back to the industry? You've already given so much in the industry, but is there anything you can give back today on the podcast as a takeaway for everyone?
Um, I, I would suggest that the BEMS industry has stagnated now for probably 20 something years or more. And that doesn't mean it's doing a bad job or it's not doing anything that it should. But if you look at the systems as they are today, and you compare them to what was 20 years ago, there's not a lot of difference there. So good. Keep taking drinking the Kool-Aid and taking the tablets and all the rest of it, but realize that this is a mature industry, and that's not where the change is happening. In my business definition, where the fun is, where
Yeah,
the edge. Uh, in the building space, the edge is about being able to do the IoT stuff. The other edge, which I'm also involved with, is about making the building a smart participant in the energy space. So we're moving to low or zero carbon energy. And the building is a consumer of energy, and it's used to being a consumer when it fancies it. It expects to have it on demand.
hmm
And But in fact, if you're a bit smart, you can use the technology to change when the building uses its energy. You know, you can preheat, you can pre-cool, you can do various things to make not not 0 to 100%, but you can make the building an adaptive load. You can start doing things like putting batteries on the site, so you charge up during the and do arbitrage. So you charge the battery when it's cheap at night, and then
Yeah,
you
yeah.
use it during the day and intelligently use it to deal with demand response events, which is largely what I'm doing in the States. Also, use it to handle peak demand charges, triad points, and things like that,
Hmm.
and just make the building a whole lot more intelligent. And again, people tend to be that they're either on the supply side or the demand side. You know, they're either on the energy supply side and they don't understand what the uses are, or they're on the demand side and don't understand what the constraints or opportunities are on the grid.
Yeah.
But there are huge opportunities on the grid because you can get away from fixed price tariffing, and you can get into dynamic costing, and so
Hmm.
you can make your buildings more adaptive, and you can do that by manipulating the existing BEMS, as long as you know what you're trying to do with that. So I think there's alongside making the buildings more intelligent through the analytics type of space to make sure that everything's doing what it should be doing, spotting opportunities for preventative maintenance or efficiency-based maintenance. I'm not doing this because it's broken. I'm doing this because the efficiency's dropped off in the same way
Yeah.
as my car, needs its oils changed and its filters changed and things like that.
Yeah.
So you can do that. But I think yeah, making buildings a grown-up participant in the energy world and being interactive is one of the next challenges that I think we're going to see.
Yeah. Well, Terry, once again, I'd like to say thank you very much for joining us today, and,
My
and sharing
pleasure.
your story.
It's nice to see you, and I'm glad the world has worked out as well as it has for you.
Thank you very much. And please, Terry, you and your family, please stay safe in these times.
Thank you.